Just a note before we get into this too far, I do have 3 of the schools I have the test for. Hurley, I don't have yours yet. So if you maybe want to just say something to the person who coordinates there, make sure if they haven't sent them that they do, or if they have sent them, maybe have them resend them because they didn't come through. Everybody else, your test should be back at your contact person, so they should be getting them back to you soon. And I'll answer questions. Hopefully by Wednesday I'll have everybody's in and graded, and then I can answer some questions on those if you need me to. So anyway, this question here is like what we did on Friday, dealing with dilutions. So we have a urine specimen that exceeds our meters limits. So we're diluting 250 microliters of urine with 1 milliliter of saline. So our diluted reading of 172, we need to find that true reading. So the first thing we have to do is find the dilution. So the dilution, remember, is the concentrate. In this case, that'll be the urine over the total solution. So the urine here is 250 microliters. Our total solution is the urine plus the saline. Now our issue here, of course, is that these are in different units. So I'm going to convert that 1 milliliter to 1,000 microliters. So that gives us 250 microliters over 1,250 microliters. And as we reduce that, microliters cancel out. Both of those numbers can be divided by 250. Gives us a 1 in 5 dilution. Once we have the 1 in 5 dilution, that's what we use then to adjust that diluted reading. Because the 172 is the smaller of the two numbers, the diluted reading is smaller than the true reading, it's going to go with the 1 here. So 172 milligrams per deciliter, and we will cross multiply and divide. So 5 times 172 divided by 1 is, I believe, 860 milligrams per deciliter. So show of hands, how many of you had that? Okay. Anybody have questions on how we got to that? Wants me to go through another example of that quick before we move on? Okay. So now that we've worked with these dilutions, we're going to step back and we're going to continue with the dilution, but we're going to step back and look at the solutions and that concentration that we talked about at the end of the first unit. Actually, the beginning of the second unit, I should say. But remember, that solution has 2 parts. We have the solvent, which was non-medicinal in most cases. Usually that is saline, so there is no active ingredient in there, no medicinal value. And we have the solute, which is our medicine, which is going to be our serum in this case. And if you recall the amount of that active ingredient, so the amount of serum in that solution was equal to the concentration times the total volume. So if we had 300 milliliters of 24% solution, that meant the amount of serum, the amount of the active ingredient in there was really 24% became 0.24 times the amount of 300 milliliters gave us 72 milliliters of that active ingredient. So what we're going to look at today to start off with is what happens if we actually dilute a solution that's already done. So we start out with let's do this. 300 milliliters of 24% solution is diluted with 900 milliliters of saline. Find the new concentration. So if we look at this, what we had for an active ingredient before, so the amount of serum in here is 0.24 times that volume of 300, which is 72 milliliters. So that's how much active ingredient we have. Now, if all we're adding to that is saline, the amount of that active ingredient will not change. So we still have 72 milliliters of that active ingredient. We are looking for the concentration. I'm just going to call that C for now. Our new volume, we had 300 milliliters, and we're adding 900 milliliters to it. So 300 plus 900 is 1,200 milliliters. So that our new concentration can be found by solving this equation, dividing by 1,200. Well, 72 divided by 1,200 is 0.06 is our concentration. So we're now at a 6% solution. Well, most of the time, we're not just flat out given the amount of saline that's added. A lot of times, we're instructed to take it through a given dilution. So let's say that we have 120 milliliters of 78% solution is diluted 1 in 4. Find the new concentration. So as we're looking at this, we have that 120 milliliters of 78% solution. So the amount of active ingredient there is the 0.78 times 120. So 93.6 milliliters of active ingredient. To figure out how much total volume we have here, we have to go through that dilution. So we have a 1 in 4 dilution. Remember, 1 is the concentrate. In other words, that's the amount of the 78%. And the 4 is the total solution again, after it's diluted. So the 78% is 120 milliliters. To find how much we have after the dilution, we cross multiply and divide. 4 times 120 divided by 1 will give us 480 milliliters. So what we have here now is we still have 93.6 milliliters of that active ingredient from up here equals our new concentration times 480 milliliters is our new volume. So we just divide it out. So we divide by 480 and we get 0.195 equals our concentration. So 19.5% is that solution. So let's take a look at another way of looking at that. Let's say what dilution is required to dilute 360 milliliters of 48% solution to 8%. So So here we're looking at what dilution needs to be performed. So again, we're going to start out looking at that active ingredient. So the amount of serum here, 48% is what we're starting with, 0.48, and our starting volume is 360. So we do 0.48 times 360. We get 172.8 milliliters of our active ingredient. Now we need to figure out how much we have to add to that to get it to 8%. So we have 172.8 milliliters. Goes 0.08 times whatever this volume is. So we're going to take our 172.8 divided by 0.08. We get 2,160. Is that new volume. So it's milliliters. So the dilution necessary, remember that dilution is the concentrate, the 48%, over the volume of the 8%, the total solution. So we're going to have 360 milliliters on top over the 2,160 milliliters. Milliliters divide out. Both of those will divide by 10, giving me 36 over 216. Both of those will actually divide by 36, which gives me 1 in 6. So that is a 1 in 6 dilution that will dilute that from 48% down to 8%. Now, if you're looking at these carefully, you will see here the ratio of the percent, so the concentrations. The new concentration to the old concentration. 0.08, 0.48, or we just have 8% over 48%. It doesn't matter. As long as they're both percents, we don't have to turn them into decimal form. If I divide that out, that is a 1 in 6 ratio. So the ratio of the concentrations is equal to the dilution necessary to dilute it down to that concentration. This is basically the same type of problem we were doing at the end of or the beginning of the last unit with those mixture problems, only now one of the solutions is going to be just saline, so a 0% concentration to begin with. So we could look at how much saline is required to dilute 200 milliliters of 18% solution to, let's take it down to 4.5%. So as we look at that, the first thing we want to figure out is what our dilution is. So our dilution is going to be, again, the new concentration, the smaller one, over the old one, the larger percent. So we've got 4.5 over 18%. And to reduce that, percents cancel out. I have to get rid of the decimal within my fraction. So 4.5 times 2 is 9. I take 18 times 2 to give me 36. And both 9 and 36 will divide by 9. Gives me a 1 in 4 dilution. Now that I know that it's a 1 in 4 dilution, now I have to be careful now. The 1 is no longer describing the 4.5% here. The 1 is now describing the concentrate. Now that I'm treating as a dilution, the 1 is the concentrate and the 4 is the total solution. So that is after it's diluted. So the volume we had of the concentrate, or of the 18%, is the 200 milliliters. To find the volume of the total solution after we dilute it, 4 times 200 divided by 1. So that's 800 milliliters. So the final amount of 4.5% solution we have is going to be 800 milliliters. So we started out with 18%, 200 milliliters. We ended up with 4.5% and 800 milliliters, but we have not yet answered our question. The question was, how much saline is required? How much saline do we have to add? So we're going to subtract those. The difference between them has to be what's made up with the saline. So 600 milliliters of saline. So once we know that the ratio of the percents is going to be equal to our dilution, then it simplifies the problem. In fact, we can go the other way. Find the new concentration if 720 milliliters of 27% solution are diluted with 360 milliliters of saline. So the first thing we're going to figure out here is the dilution. And in this case, we have the amount of the concentrate which is the 27%. And we're going to find our total solution. So the amount of concentrate, we had 720 milliliters. Our total solution is going to be that 720 milliliters plus the saline we added of 360 milliliters. So that puts us at 720 milliliters over 1,080 milliliters. So the milliliters have the same unit, so we can cancel off the milliliters. Both of these will be divided by 360. 720 divided by 360 is 2. 1,080 divided by 360 is 3. So this is a 2-in-3 dilution. And since it's a 2-in-3 dilution, we can go back to what we learned above, that the dilution is equal to the ratio of the concentration. So 2-in-3 is the dilution. For the concentrations, remember, it's going to be the new concentration on top, because that's the smaller one, over the old one, which should be the larger of the two. So the old concentration was 27%. We are looking for the new concentration. So we're going to cross multiply and divide. 2 times 27 divided by 3. Well, 2 times 27 is 54%. Divided by 3 is 18%. So that new solution after that dilution is 18%. Well, this process that I've been going through here, using that dilution formula, works rather well. But there's a simpler way that we can look through things. We saw before the amount of the active ingredient was the concentration times the volume. Well, since we are only adding saline to it, that amount of active ingredient does not change. So what that means is that amount is going to be the same before we add the saline as it is after. So the before, we're going to label that C1 as concentration 1 times V1, the volume 1. So that's the starting concentration times the starting volume. That's the amount of active ingredient before we add the saline. Has to equal the amount of active ingredient after, which would be C2 times V2, volume 2. So let's say find the concentration if 240 milliliters of 12% solution is diluted to 960 milliliters. So our formula C1 V1 equals C2 V2. That formula, by the way, might look familiar. It was one of your formulas that you had to solve by rearranging the letters on the last test. So anyway, we started out with a concentration of 12%. Now I could either put it as 0.12 or I can leave it as 12. It doesn't matter, but whatever I do on one side of the equation, I have to do on the other side. So I'm just going to leave it as 12 rather than 0.12. My volume was 240 milliliters. Equals my new concentration is what I'm looking for, that's C2, times my new volume of 960 milliliters. Now I could put milliliters in here, but as long as I am sure that both of those are the same units, I don't need them. I can cross them out. So now it's just a matter of solving this equation. 12 times 240 is 2,880 equals C2 times 960. And we solve it by dividing by 960. So 2880 divided by 960 gives me 3. So my new concentration, now since I started out with those not converted into decimals, they're already percents. So what I get here is a percent, so that is 3%. If I had converted that to 0.12, my answer would have been 0.03, so then I would have to move the decimal to make it a percent. Like I said, I find it's just easier to leave them as percents and not deal with the decimals. So after that 240 milliliters of 12% is diluted to 960 milliliters, it has a concentration of 3%. Find the new volume after 60 milliliters of 64% solution is diluted to 8% solution. So again, on the before side, we have 60 milliliters of 64%. So 64% times 60 milliliters. On the after side, this time we know the percent. We know the concentration is 8%. We are looking for the volume, volume 2, V2. So now we're going to multiply. 64 times 60 should be 3840, I believe, but we're going to double check here. And it is 3,840 equals 8 times V2. And we solve by dividing by 8. So that's 480. The units here on the 60 were milliliters, so the 480 is in milliliters. So the volume after we dilute it is 480 milliliters. quite often this formula is more useful going in the other direction. Let's say we need a certain amount of a certain concentration, and we want to know how much we have to start with. So you might ask, how much 36% solution is required to create, let's do 210 milliliters of 4% solution. So looking at this, we are starting out with 36% solution, but we don't know how much we have. So 36 times V1 equals, we're ending up with 4% solution, and we need 210 milliliters of it. So now again, the milliliters are only here to tell us that this volume will be in milliliters as well. So 4 times 210 is 840. And we'll solve it by dividing by the 36. So V1 equals 840 divided by 36. So 23 and 1/3 milliliters is that initial volume. Okay, so this can be done, we can use this for a little bit more complex problems then. We might ask, how much saline should be mixed with 360 milliliters of 42% solution to dilute it to, let's go 14%. So we're going to start out with the same formula. We're starting out with 360 milliliters of 42% solution. So 42% times 360. That's what we're starting out with. That's our before. After we dilute it, we're going to be at 14%. So that's our second concentration. It'll be 14. We are looking for, or we're going to find at least for now, the second volume, V2. So 42 times 360. 15,120 equals 14 times V2. So we'll divide by 14. So 1,080 is our new volume. Well, remember what V2 is the volume of the 14% solution. Is that what we're looking for here? No, we're looking for how much saline do we need? Well, our volume went to 1,080 milliliters from 360 milliliters. The difference had to be made up with saline. So the difference is 720 milliliters, which is telling us we had to add 720 milliliters of saline to dilute that solution. Any questions there? Okay. So what if we have 120 milliliters of (44% solution is diluted with Oh, let's do it. 480 milliliters of saline. Find the new concentration. So we started out with 120 milliliters of 44%. So that's 44 times 120 milliliters equals, we don't know our new concentration, so C2 is what we're looking at. And we're multiplying by the volume here is going to be the original 120 milliliters plus the 480 milliliters of saline that we added. So 44 times 120 is, I believe, 5280. I'll double check it just to be sure. It is. Equals C2 times 120 plus 480 is 600 milliliters. And now we're going to divide out. We'll divide by 600 here. Gives us 8.8. So this is an 8.8% solution after being diluted with that 480 milliliters of saline. So as you can see here, there are a lot of different combinations and different angles of approach that can be taken with these dilutions. And different ways of diluting formula. And it's much simpler than that solution mixture problems we were doing last unit, because we're diluting it not with another solution, but with just the pure saline, non-medicinal. So let's combine this formula with our dilutions. So let's say we have 180 milliliters of 20% solution is used in a 1:5 dilution. Find the volume and concentration of the new solution. There are actually a couple of different ways we can approach this. We can actually use the dilution of 1:5, compare it to our ratio of concentrations, which will be our new concentration over our old one of 20%. And we can cross multiply and divide. 1 times 20 divided by 5 means we're going to be looking at a 4% as our new solution. So then we can use that along with that our concentration adjustment formula, or change of concentration formula. We had 20%, we had 180 milliliters of it. We changed it to 4%, so we need to figure out how many milliliters we have of that. So 20 times 180 is 3,600 equals 4 times V2. We divide by 4. We get 900 milliliters is V2. The other way we could have done that is we could have used our dilution of 1:5, remembering that the 1 is the concentrate, so that's the amount we have of the 20%, and the 5 is the total solution. And we had 180 milliliters before. If we do 5 times 180 divided by 100, or divided by 1, I should say, that is 900 milliliters afterwards. And then we could use that in our formula. We have 20% We had 180 milliliters of it, equals, we could find our new concentration if the volume is the 900. And the process is going to look pretty much the same. 20 times 180 is 3,600. And then to find our concentration, we divide by 900. 3,600 divided by 900 is 4. So that's 4% is our new concentration. So most of these problems, and really this, all of Unit 3 here, a lot of these problems are going to have more than one direction that we can take with them. More than one formula. We can use the dilution formula, or we can use the concentration adjustment or change of concentration formulas. As we look into our dosage calculations, there's going to be at least 3 different methods we can use for all of those when we hit those at the end of the week. Probably won't touch those this week. We might have to wait till after spring break. So the key here now is finding a method that you are comfortable with and that works with you, and using that method to solve these problems. I realize we have a few minutes left here, but that's really all of our new material for today. Homework that covers this material on page 134, 1 through 11, the odds. This is going to be that dilutions, using the dilutions to change concentrations. And then on page 138, 1 through 17, the odds. That's going to be that change of concentration formula. C1V1 equals C2V2. And all the different applications of that. Again, those of you in Hurley, if you had mentioned to your contact person there to resend those tests if they haven't sent them yet. Okay, thanks. With that, I'll let you guys have the last few minutes to get started on that if you want to, or whatever else you need to get done. And you guys have a great day.